Hey everyone, in today's video, we're going to be starting with the concepts of redox. Here, we're going to start with the revision of the O-level concepts of redox reaction. So we have reduction and we have oxidation. We know that when we talk about electrons, reduction is gain of electrons, oxidation is loss of electrons. When we talk about reaction with hydrogen, which basically is H2 or atomic hydrogen, it is a reaction with hydrogen. Reduction is a reaction with atomic hydrogen, and oxidation is loss of hydrogen. If I were to talk about oxygen gas, which is O2, then oxidation means reaction with oxygen gas, and reduction would mean the loss of oxygen. With some basic examples, we'll also come across more of them. So first, we're going to have some very basic examples. For example, copper reacts with oxygen. Copper was solid, oxygen was gas. We get copper oxide. This was half mole. And now we have solid copper oxide. So here, basically copper is oxidized. So we can say copper is oxidized. And obviously, baat hai, if copper is oxidized, oxygen gas is reduced. I'll explain you very soon how this works in terms of oxidation numbers. Another example we have is, let's suppose nitrogen reacted with hydrogen, both were gases, and they eventually make 2 moles of ammonia gas. This was 3 mole, this was 1 mole. So nitrogen is reacting with hydrogen, so it is, going back to my notes, reaction with hydrogen is reduction. So in this case, nitrogen gas is reduced. And obviously, if nitrogen gas is reduced, the other element, which is hydrogen, it must have been oxidized. But in A level, we should be able to understand, even in O level, we should be able to understand this whole idea in terms of oxidation numbers. So let's talk about oxidation numbers. What are these and how we can use them to understand redox even better? So oxidation number represents, it's a number that represents the number of electrons lost or gained by an element. It could be even a compound, but even there, oxidation number is basically found out for a single element. It is never for a whole compound, it is for the whole element. Let's take some examples. For oxidation numbers, we have some rules to understand them. So the first rule is pure element has oxidation number is equals to 0, which means that Na as an element, iron as an element, H2 as an element, sulfur 8, which is solid, as an element, maybe F2 gas, maybe Cl2 gas, any other element, any element. For example, argon as an element. All these elements have oxidation numbers of 0. They have no charge, their oxidation number is 0. We have a second rule that says the charge on a monoatomic ion is its oxidation number. What's a monoatomic ion? It's a single atom with a charge on it. For example, N3 minus is oxidation number is equals to -3. Fe2 plus has an oxidation number of +2. Getting it? Chloride with a minus ion has an oxidation number of -1. Another example could be, let's say, any ion. Sodium +1 has an oxidation number of +1. Charges are written as 1 plus, not +1. Any other example would be, for example, oxide with a 2 minus has an oxidation number of -2. So these are monoatomic ions. Let's add one more page for the next rules that we're going to have to talk about. Oh, sorry, they're done. So let's take one more page. Why is it not working? Blank page. Yeah, done. Okay. So I can work here also. You know, this would never happen, but since it's being recorded, it has to happen. So we have a rule number 3. Rule number 3 is, if you're dealing with a polyatomic ion, then each element has its own oxidation number. So in a polyatomic compound or ion, each element has its own oxidation number. For example, let's talk about compounds where total oxidation number is equals to 0. For example, when I talk about a very simple example, HCl, hydrogen is supposed to be +1 and chlorine is supposed to be -1. How do we know this? We know this from the group number. When I talk about H2O, hydrogen, there are 2 atoms, each is +1 times 2, and oxygen itself is -2 because oxygen is group 6, it always has to be -2. Another example would be, for example, let's say a 3-atom compound would be CO2, a very simple example. CO2, carbon is group number 4, oxygen is group number 2, or group number 6, I mean. Oxygen has an oxidation number of -2 because it is group number 6. Oxygen always makes a -2 charge whenever it is in a compound. Oxygen makes -2 when it's in a compound. So there are 2 oxygens, so that's -2 times 2, which means -4. Carbon has to be +4 so that the total can be equal to 0. Another example would be, let's suppose FeCl3, which is also called, I can't tell you the name, otherwise you'll know what the oxidation number is. I know that a single iron is here, and I know there are 3 chlorides. Each chloride is -1 because chlorine is group 7. So -1 times 3 because there are 3 chlorides, which becomes -3. There's a single iron ion which is electrically cancelling all 3 chlorides. So the iron has to be +3. Simple as that. For example, if I were to talk about ZnSO4, now my previous knowledge is that sulfate is a -2 ion. You don't have to deconstruct these ions if you know them already. So I know this, that sulfate is -2. So sulfate is -2. Zinc has to be +2 because a single zinc ion cancels a single sulfate ion. Another example would be, let's suppose Cr2O3. There are 2 chromium ions and there are 3 oxide ions. Now, we know this, that a single oxide is -2 and there are 3 of them, so that becomes -6. If that is the case, then the 2 chromiums should be +6. -6 is because of the oxides, +6 should be because of the 2 chromium ions. What should be the charge of a single chromium ion? So 2 chromium ions should be +6. A single chromium ion should be +3. Simple as that. So single chromium is +3. That is why we might as well call this compound as chromium 3 oxide. The first compound that we mentioned was iron 3 chloride. So the number written after the name of the metal is often a representative of the oxidation state. So we talked about few compounds right now. It would be better to talk about some polyatomic ions where we deconstruct each individual element. And that would be another example that in polyatomic ions, total oxidation number is not equal to 0. It is equal to the charge of ion. Let me give you a very basic example. For example, a very basic example would be NH4 ion. I don't know about nitrogen, I don't know about hydrogen, but I know that the total is going to be +1. So +1 is equals to single nitrogen, and it is equal to a combination of 4 hydrogen atoms or ions, you can say that. A single nitrogen is, I don't know, but I do know that 4 hydrogens are each +1, and that is equal to +1. Each of the 4 hydrogens is +1. So when I solve it, it becomes N is equals to +1. This thing goes there, which means -4. N is equals to -3. So nitrogen's oxidation number is -3 over here. Let's take another example. Sulfate ion, which is a charge of -2, 2 minus, I should say. There is a single sulfur atom, and there are 4 oxide ions. They together give you a charge of -2. I don't know about sulfur, but I do know that each oxygen is 4 times -2, because like there are 4 of them and each is -2, so they can -2. Sulfur plus -8 is equals to -2. Sulfur is equals to -2 plus 8, which is +6. So sulfur's oxidation number here is +6. Nitrogen there was -3. Let's take another example to clarify this understanding. Let's talk about nitrogen in the nitrate ion. Whether I say nitrate or I say sodium nitrate or potassium nitrate or nitric acid, it is always nitrate, NO3. So just don't confuse something else. Sulfate is the same sulfate, whether it's sodium sulfate or potassium sulfate or sulfuric acid. The sulfur is still the same. So nitrate, whether it's sodium, potassium, nitric acid, whatever, let's talk about it. There's a single nitrogen over here, and there are 3 oxygen ions over here, and that gives you a total of -1. Now nitrogen plus 3 oxides is equals to 3 times -2, because each oxide is always -2. Nitrogen plus -6 is equals to -1. Nitrogen is equals to -1 plus 6, which is equals to +5. So nitrogen's oxidation number in nitrate ion is +5. Let's have a few more examples. For example, I'm going to be talking about this compound called NaClO3. It's a very common compound. You will be seeing it eventually. So for example, we know that sodium is group 1. Sodium has to be +1. There's a chlorine over here that I don't know anything about. There are 3 oxides, and that's a total of 0 because it's a compound, not ion. You don't see a charge over here. It's not an ion. Sodium is +1. Chloride, I don't know. 3 oxygen is 3 times -2 because each is -2, 0. +1, chloride, -6, 0. Chloride is equals to +6 -1. Chloride is equals to +5. So the oxidation number of chlorine atom here is +5. And that is why you can see the name sometimes written as sodium chlorate 5, because the 5 is the oxidation number of chlorine ion over here, chlorine atom within the ion here. nitrate is basically nitrate 5 because nitrogen has an oxidation number of 5. So today's video, we talked about the oxidation numbers. And in the next class, we're going to be talking about some balancing of equations. Stay tuned.